This is your first lesson on reciprocal trig functions, and we'll introduce what they are and try some exam style questions. Here are your starter questions to get you in the mood for trig. Here are the mark schemes. And now a few questions just to make sure you're fully on top of the notation. You'll need to pause the video quite regularly. You first met trig when you were considering similar triangles, so just remembering that similar shapes might be a different way up and they might be a different size, but what they have got in common is they'll have all the angles the same, and they'll also have the side lengths in the same ratios as other similar shapes. So here are some examples. You can solve lots of problems if you know the ratios of the different sides. So with right angle triangles, if we know one other angle as well as the right angle, that automatically means we know the third angle. So we have similar triangles. If we label one of those angles, then we can kind of label the sides opposite, adjacent, hypotenuse, and we have named some of the ratios because we use them so often. So we've named opposite of a hypotenuse, we've called that sine, for example. Okay. But there are other pairs that we could have done. There are three other pairs: hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. And those are the reciprocals of the ones we've got, so we call them the reciprocal trig functions. Here they are. They're called secant, cosecant, and cotangent. We abbreviate them to sec, cosec, and cot. Now the cosec one is sometimes written CSC in some textbooks or online. The little trick for remembering which trig function name goes with which function is to look at the third letter. Okay. If you are looking at the third letter of sec, you get a C, and that's the initial letter of cos, and sec is the reciprocal of cos. If you look at the third letter of cosec, it's S, that's the initial of sine, and cosec is the reciprocal of sine. And similarly, the third letter of cotangent is T, and cot is the reciprocal of tan. You can see the adjacent opposite sides, etc. listed there too. One thing to watch out for is that even though these are reciprocals, and we know that to the power of -1 gives you reciprocal, we can't write, for example, cos to the -1, because this means the inverse of cos. To get the reciprocal of cos x, you'd write cos x in brackets and then put a -1 outside. It's a bit confusing because cos squared x means exactly the same as cos x in brackets squared, but it doesn't work for the -1 because the -1 means the inverse. Test out that knowledge on the next few questions. Here's the answer, and the answer, and the answer. Now, unfortunately, your calculator doesn't have a sec, cosec, or cot button, but you can just type in the fractions on your calculators, and the next example will show you that. For example 1, we just have to work out values of sec and cosec and cot. So first of all, we know that sec, we look at the third letter, and that tells us it is the same as 1 over cos of 40 degrees. So I get my calculator, and first of all I'm going to do shift to get set up and make sure that my angle is in degrees. There we go, and I will do 1 over cos of 40. There we go. So there's my answer, 1.31. Okay, right, let's look at cosec of pi over 5. We look at the third letter. That reminds us we have 1 over sine pi over 5. Okay, so I need to be back in radians for this one. So we go to setup and we change back over to radians, and we do 1 over sine of, and then again a fraction, pi over 5. Okay, and that gives us 1.70. Okay, and then we're back in degrees again for the third one, so off we go again. Alright, so again I want a fraction. Now cot is 1 over tan. Okay, so we do 1 over tan of 250. Okay, and that gives us positive 0.364. Okay, right, for the last one, we're given that tan of pi over 6 is 1 over root 3, which we ought to know anyway. Find the exact value of cot 5 pi over 6. Okay, so it's not the same angle, but it is related. Now, to do this one, it would be a good idea to use a cast diagram. Okay, and look at where 5 pi over 6 is. Okay, well we know that we go from 0 round to pi over 2, which would be 3 pi over 6, and then we keep going to get to pi, which would be 6 pi over 6, so we know it's going to be in the second quadrant here. We know that this is 5 pi over 6, which just leaves a single pi over 6, which is very useful, okay, in this area here. So that means that to get our cot of 5 pi over 6, that's going to be the same as doing 1 over tan 5 pi over 6, and we know that tan of 5 pi over 6 is going to be related to tan of pi over 6. Okay, right, tan of pi over 6 is acute. Pi over 6 is acute, so tan will be positive. But here, the only thing that's positive is sine. And so we know the tan of 5 pi over 6 would be negative tan of pi over 6. Okay, so we want to do the negative reciprocal of 1 over root 3. So that gives us minus root 3. Okay, if you prefer, you can draw the tan graph instead. Okay, so we'll just see how that works. If we drew the tan graph, okay, here is pi over 2, here is pi, and so we know that 5 pi over 6 is going to be here, and that is showing us that tan is negative, but pi over 6 is here, which shows us that tan is positive, and it's the same distance, okay, from pi as pi over 6 is from 0. Okay, so we know we have the same value, but we end up with negative. I find it easier to follow cast, but you can use the graph if you prefer. And let's have a look at your marvellous calculators. So this time I want to do 1 over tan of, and it's 5 pi over 6. Now before I press go, I'm going to just check. I was in degrees, I need to be back in radians, and now I can execute, and it gives me it exactly. But older calculators can't give you it exactly. That was the worked example 1. Here are the answers again. Here are some practice questions for you. In order to get more out of them, because they're fairly straightforward, after you've done the first one, have a look at the second one and think about, well, what's the difference between this and the one before it? See if you can predict what your answer might be, or any ideas about the answer. Okay, and then check it by working it out. See if you get a surprise, or if you get what you predicted, can you explain that connection? Okay, here are the answers. And here are some more questions, this time working in radians. Here are the answers. You'll learn more about number 9 in the next lesson on graphs. Here are some extension style questions. I have to think a little bit differently. And here are the answers. Here's a second worked example. Here's our second example. This is in the style of a classic exam question. So you're given the value of one trig function, okay, and we're given a range of values for the angle, and we have to find the exact value of a different trig function, and one here. Okay, now you might think you could use your calculator and just do like inverse tan of 15/8 and then sine it, but if you do that you'll get a decimal. It'll give you a good check for your answer. You can check that your answer matches that, but we're asked here for finding the exact value, and so that means we have to show our working out. Okay, so let's start with the information we're given. So cot theta. Now we know that cot is 1/tan, and tan is opposite over adjacent, so cot is adjacent over opposite. Okay, I can use that information to draw a little triangle. Okay, I'm going to pick an angle in the corner there. And so my adjacent side will be here and my opposite side will be there. I'm ignoring the sign at the moment. We'll deal with that after. So now if I do 8 squared plus 15 squared, that gives me 17 squared, so we get 17 on this side. Okay, so now I know the value, the size of sine theta, because that's opposite over hypotenuse, 15/17, but I don't know if I should have a positive or negative value. So to help me decide, I draw a cast diagram. Remember, the letters represent which of the trig functions out of sine, cos and tan are positive in that quadrant. We measure all angles from the positive x-axis, and we're told that our angle is between 3π/2 and 2π. So we go around, there's π/2, there's pi, there's 3π/2, we keep going to 2π, so somewhere in this region. So I'm going to draw my stick there. I always draw the angle made with the x-axis. Okay, so in this region we can see that the only thing that is positive is cos. So that tells us that sine will be negative. For our second part, we want sec squared. Now that's good news. Having a square means that the sine will be positive. We just have to remember that sec is 1/cos. Cos is adjacent over hypotenuse, so sec will be hypotenuse over adjacent. I made a mistake over here. Okay, now looking at our triangle, the adjacent is 8 and the hypotenuse is 17, so we have 17/8. So when we square that, we end up with 289/64. Okay, so that ends part A. The second part of the question is quite similar. Okay, slightly different information. So we're given that cosec is -7/6, and we're also told that tan theta is greater than 0. We're not given the range of values for theta. We have to find cos. So let's start from the information given. So we know that cosec is 1/sine, and so that means it will be hypotenuse over opposite. So I'm going to draw a little triangle and put that information on the triangle. So I'm going to use 6 for my opposite and 7 for my hypotenuse, and I'm ignoring the sine again. So if you do 7 squared take away 6 squared, you get 13, so this will be √13 on that side. Right, we have to find cos, so we know it's going to be adjacent over hypotenuse, but we need to know what the sine is. So again, I'm going to do a cast diagram to help me decide. Okay. Right, so measuring from the positive x-axis, going in the positive direction, I know that cosec is negative, alright, and I also know that cosec is 1/sine, so that tells me sine is negative. Now the A means all of them are positive here, sine is positive there, So it must be one of these two areas that we want. So sine is negative in those two quadrants. Then we're also told that tan is greater than 0. So tan is greater than 0 in the all or greater than 0 zone and in the t zone. So this is our overlap. So we know that our angle must lie in this quadrant. Okay. And we know that in this quadrant the only thing positive is tan, so cos is negative. So if you're a graph person, it's a bit more of a palaver for this one, but it still works. So we start by thinking about cosec being negative. So cosec is 1 over sine. Okay. And so we can see that sine is negative for this range of values here, from pi to 2 pi. Okay. And then we need to think about tan being positive, as we're told. So we can see that tan is positive in this zone and this zone, and then we can see that they match up between pi and 3 pi over 2. So we want to find out, is cos positive or negative in that region? Okay, so we are now looking at this bit here, and we can see that cos is indeed negative. Here are the answers again. Here are some practice questions for you, very similar to those. Again, you'll get more out of it if after you've done one, you then try and predict what you'd expect for the next question, then work it out and see if you were right, looking for the little changes. That will help you think mathematically. And here are the solutions. And now we've got some exam questions for you. Question 2 is pretty challenging and question 3 is pretty left field. Here are the solutions. Well done.